So, so, hello everyone, hope you're doing good. Welcome back to my channel. Today is day 3 of the April Daily Report Challenge, and we have a medium level question in front of us. It's question 881, Votes to Save People. Okay. So, this question is a very simple question. Here, what we're given is we're given the weights of people. There are n peoples, and we have the weights of n people. There's a limit given. So, what we have to do is we have to transfer these people through a boat. The boat, see, there are two conditions for the boat. The boat can carry only two people. Okay, at max it can carry only two people, but it can carry two people only when the weight of their, like the sum of their weight, is less than or equal to limit. Okay, two conditions are that for the boat. See, boat can carry either a one person or two person. If it carries two-person, then sum of their weight should be less than or equal to limit. At any cost cannot carry more than two-person, right? So this was a brief about this question, and let me see if I missed anything. So given array people where people is the weight, okay, and the infinite number of boats. See, we finally have to answer what is the minimum number of boats to carry every given person. For example, in this case, you can see limit is three, right? So at max I can carry two people. Let me see if their sum is equal to or less than three or not. So in this case, it is equal to limit. That's why I can carry both of them in one boat. So the answer is only one boat is required. Okay. Now see this case. So in this case, what I can do is I can see start with three. Okay, three is equal to the limit, so I can send three alone in one boat. Then I can send these two persons in one boat, and I can send this person in one boat. So total of three boats will be required. Okay, and similarly here limit is five. Okay, this person I can send in one boat, and yeah, each one of them will go individually in one boat. Okay, there is no other way here. So yeah, that was all about this question. And if you are aware of how to solve this kind of, see, this is just like a puzzle, right? So what we try here is we will always try sending the heaviest person with the lightest person. We'll just see, because see, they have given a condition at max two people only can go. So we're just trying to see if the heaviest person and the lightest person, if we add their weight, if it is less than or equal to limit or not. If it is not, then see, just send the heaviest person alone, right? Then we take into consideration the second heaviest person and the lightest person, and similarly this thing goes on. Okay, we see, if the heaviest person can be sent with the lightest person, that will be great, right? Because two people we are sending in one boat, so a boat will be reduced finally. So that is the optimization here. And coming to the solutions part, see, we are first of all sorting the array. So the lightest person will be at the index 0 and the heaviest person will be index and minus 1. Okay, and is the length of the people's array. I'm initializing j with the initial index and initializing, sorry, I with the 0 index and j with the last index. Okay, so this is going to be my answer. Okay, so I will be running this loop till I is equal to j, means till I is less than or equal to j. For every attempt, one board will be required, right? I'm just checking if the ith people and the jth people, I is the smallest people currently, which I have not sent, and j is the highest people currently, which I have not sent. If the limit, if the sum is less than, if the sum of the weight is less than or equal to limit, okay, that means I can send him together. That's why I will do I plus one. If this is not the case, I will send only the heaviest person. I will send only the heaviest person. If this condition is true, I can send with the heaviest person, the lightest person available. If this condition is true. If this condition is not true, then whatever be the case, I will at least send the heaviest person. Okay. And if this question is clearly given that the heaviest person weight, it will always be less than or equal to limit. So I don't need to check again that explicitly. Okay. So I will just quickly run and show you. I have done the tracing as well. I will show the tracing of after this. Okay. This is clearing all the test cases, right? Now coming to the tracing part. For tracing, I'm using this second example, right? I'm using this second example. So this is the people set given to us. After sorting, it will look like this. Okay. So first, I will be initialized with a zero, and the j will be initialized with three, and limit is three, right? So I will just check if one plus three. Okay, if it is less than or equal to limit or not. It is not so, right? One plus three is not less than limit. Okay, it is not less than limit. Less than limit, right? So what I will do is boat one will be for the heaviest person. So this person will go in the boat one. Okay. I will do j minus minus after that. So I now I will consider I is equal to 0 and j equal to 2. Okay, this person and this person. If we add their weight 1 plus 2, it is definitely less than equal to 3, which is the limit. Okay, so 1 plus 2 is equal to limit. That means both 2 is for this person and this person. I equal to 0 and j equal to 2. And finally, I'm left with I equal to 1 and j equal to 1. This depends the same person. Okay. So this person will have one vote. So both will be for I equal to j equal to 1. Okay. So in total, we require 3 votes. And in this also, you can say the answer is 3. India. We have also done exactly like this. So what is the up? See, what we are doing is, see, we are basically we are trying to send the heaviest person with the lightest person, because it's clearly given that the boat can carry at a max 2 persons only. That also only if there some of the weight is less than equal limit. Okay, and if we try to understand the time complexity of it, see, we are using a searching here, right? Searching is involved here, so it will be definitely of the n log n time complexity, and this thing is almost like O of n. But since n log n is greater than O of n, that's why the final time complexity will be O of n log n. And space complexity, we are not doing anything space explicitly, just O of 1, constant space complexity. Okay. So yeah, friends, that's all for today. If you have any doubts, please do comment below. And if you like my efforts, please subscribe. Thanks a lot.